evening, everybody, and welcome to this first Scan Pro Audio webcast of 2015. Happy New Year to you. As usual, this evening we have some rather wonderful goodies for you to see, and throughout the performance, throughout the description, throughout the webcast, bear in mind these two words: fizzy balls, because by sending the words fizzy balls to us in an email at the address that should be shown at the end, you could qualify for some rather splendid discounts on the aforementioned products. There's nothing that pleases us more here at Scan than rack mount boxes, especially with lots of I/O involved. And we have some rather wonderful gear here from MOTU, and happily Simon Stock, who's going to tell you all about it. So we're going to cut some titles, and when we come back, it'll be Simon.
MusicTrack, we're the UK distributor for MOTU. Thanks very much for Scan Computers for giving me the opportunity to come here this evening and talk to you all about the MOTU AVB range of audio interfaces. So this is a new generation of audio interfaces from MOTU that come equipped with a new technology called AVB audio networking. And we have the interfaces here, and also the industry's first low-cost 5-port AVB switch, which is so we'll come to those later and see how they all link up. So the first of these products appeared at the end of July last year, all featuring Thunderbolt connections as well as USB and Ethernet, and they're really starting to make waves now in broad segments of the pro audio market because their affordability for the very high audio quality, inbuilt effects, multiple complementary input and output configurations, 48-channel mixing. The list goes on, very extensive list of features that we're going to get into. And of course, the other aspect is the networking features. So let's step into that. So the first thing we will do, let's dive into how these 6 products. We've got 5 in the picture here, but there's an even newer one out now. Let's see how the features in each of them. So we'll start with the 1248, which is here on your left, my right. .1248 has got 4 built-in mic preamps. These are entirely new preamp circuits from MOTU. Exceptional audio quality. MOTU have built these audio interfaces from the ground up. It's all new technology. It's not a rehash of the previous generation, the sort of Mark III FireWire USB interfaces, all new. We've got 12 channels of line level analog input and output. The line outputs have got up to 20 dBu full scale signal, and the inputs will accept up to 24 dBu of input gain. The inputs and outputs can also be calibrated for other reference ranges, like 10, -10. All the gain settings, including the preamp gain, can be remotely controlled. We'll show you how later, and saved as presets. On the front panel, we've also got 2 high-Z guitar inputs and 2 sets of independent stereo headphone outs. For digital inputs and outputs, we've got 2 sets of optical, plus SPDIF stereo I/O. The SPDIF supports real-time sample conversion. You can also see the BNC word clock and the Thunderbolt and USB connections for the computer. The USB connection is class compliant, which means you can plug it into an iPad or iPhone. No drivers required. Works straight away. And you'll also see the AVB Ethernet network port is there. So that means in total, the 1248 has got 32 discrete channels of audio input and 34 channels of output. That's 66 physical channels of audio I/O. All these channels are available simultaneously. So here's the front panel. You can see master volume controls for the main and monitor outputs. And there are the two assignable phones outputs and the high impedance guitar inputs. Next up's the mic pre controls. Separate phantom power and pad controls for each mic pre. They provide 63 dB of available gain. All of the preamp settings can be controlled remotely, even wirelessly over Wi-Fi. The four knobs also double up as programming buttons for the interface, so you can make changes from the front panel rather than from a connected computer. You've got this lovely big blue LCD display which shows input and output levels, including for the digital I/O, so you can check what signals are coming in and out of your interface. And then over to the right, you can see the current sample rate selected and what the clock source is. So before we go on to the internal functions, let's just talk about the quality of the inputs and outputs, because that's, in my experience, that's the first and the last thing people want to know about is what is the quality like. Well, these are exceptionally high quality. They're using the latest generation converters inside them. Been very favorably compared with units costing a lot of more money. So let's have a look at the numbers here. You've got 123 dynamic range on the output, 117 dB of dynamic range on input, and that includes the mic preamps, which have the equivalent input noise of minus 128 dBu. So the word is getting out. These interfaces sound absolutely great. Don't just take my word for it. Check out, there's a on the Gear Sluts forum where they don't take any prisoners on there. There's I think the thread runs to 35 pages when I last checked, and you can see the results from what people think. They've A/B'ing them with other units, and definitely this is a big step up for MOTU, and is really pushing the envelope in terms of the quality that you get for the price. So let's move on to the next model, which is the 8M. 8M is all about multiple mic pre's, 8 analog inputs and 8 analog outputs. Each input you can configure either as a line input or mic preamp. So there's a potential of 8 channels of the mic preamp on board. Each of the preamp channels has a pre-converter hardware limiter built in to avoid clipping. The left side is very similar to the 1248, the same I/O, including optical in-out as well for expansion. In a recent firmware update, they've actually added the capability of configuring one of the first bank of the optical I/O as Toslink rather than ADAT. So you've got a lot of options there. It was a much requested feature that they're able to add in a firmware update. On the front panel, headphone jack, volume control, then the preamp mic trims, pad, phantom power switches. The numbers on this one, it's 123 dB of dynamic range on output. The mic pre's with their hardware-driven V-limit limiters have got 112 dB of dynamic range on input with an equivalent noise of 128 dBu. So if you need a lot of high-quality mic preamps, this is the one for you. The next one to talk about is the 16A. 16A is all about analog inputs and outputs. Plenty of them. 16 in and 16 out. A balanced line level inputs and outputs, all on 1/4-inch jack sockets. Rear panel the same as the other two that we've talked about. Front panel shows the metering. Otherwise, very simple. There's no preamps to control on this one. And check out the audio specs there. 123 dB of dynamic range, the same 117 on the input. Absolute top quality audio specifications using the same converters as the 1248 there. Now, since these initial 3 came on the market last summer, in the autumn around November, MOTU added another 2 units to the range. The 24AI and the 24AO, which we'll look at in a second. 24AI is 24 analog inputs, 24AO, 24 analog outputs in one single rack space. This is all connected up via D-sub connectors, 25 pin, or these Phoenix connectors, which are widely used in commercial audio installations. So with these, you get to choose if you want jacks coming off there, if you want XLRs, you get to choose. This section is the same as on the other units, except we don't have Thunderbolt in this. This is a USB or AVB unit, so it's ideal as an expansion for the other units, or you can use it in its own right via USB. That's the front panel. So 24 AO. This is if you need a lot of outputs. Identical to the other one, except reversed. It's on the outputs. There you go. So back panel looking very similar to the other one, with the metering as well. They share the same level of audio performance as the Thunderbolt units. Because they don't have the Thunderbolt, the price is cheaper. We'll get to the pricing later. We also have, it's not in my keynote presentation, but just a few weeks ago, MOTU started shipping the Monitor 8, which is another unit using the USB and AVB networking. And the key feature of that one is it can provide 6 independent headphone outputs. So used as a monitor mixer, also as an audio interface, and also as a mixing box. So it's kind of 3 units in one. And all these units can be mixed and matched. That's it's a very modular system, or you can just use one on its own. So let's dive into the inside of these units. Very powerful internal routing and mixing capabilities, along with studio-grade effects processing. These new models have got roughly double the amount of DSP processing that was in that's still in the Mark III range of MOTU interfaces. So we've got EQs, dynamics processing, reverb. There's about twice as much power, so you can apply even more to more channels. 48 channel mixer built in that's designed after a kind of large format mixing console, so it's familiar environment for that. Plus updated effects in here. So you're twice the DSP power, new mixer, updated effects. So latency obviously is a critical thing. And the total round trip input to output analog latency is just over half a millisecond when operating at 48K. At higher sample rates, that's even better, and that includes the effects processing. So yeah, analog to digital, just 12 samples. If you add in all the DSP, you get to a total of 32 samples, which is 0.667 milliseconds. So let's have a look at the control software. These interfaces are controlled from the MOTU AVB web app. So rather than having a separate application that you have to install on your computer, they have a web server built into them. So you literally just need to come into a browser. So let me just switch my pages here. And this is just Safari. But the MOTU AVB Discovery app gets installed. You can see that there. It finds my 1248, which is connected directly to the computer via USB here. And then by clicking on it, that opens up a web page where all the controls for configuring and setting up the mixing and the effects, the inputs and outputs are all on here. So any device that runs a web browser can be used to control the interfaces. It doesn't have to be the computer that's directly connected to it. These are kind of network-enabled devices. So if you have them on your same network, you could do it from your iPad. You could even do it from your Android phone. You could be standing at the back of a theater and changing a mix on there, even over Wi-Fi. So it's very, very flexible to do that. You can update the firmware from another room. They alert you to the fact there's a firmware update, and you sit there. They go and get the firmware update and upload it. It's fantastic. So the setup is very simple. There's a quick download of the AVB Discovery app. That will instantly find that you've got a device connected, and there it is. So it's basically split into 4 pages. that control routing, mixing, and device setup. To get you going, the first thing when you plug a device in is it will ask you how you're going to use the device. Is it going to be used as an audio interface, or as an expander, or as a stage box? And you can and these are provided as presets. So here they are: audio interface, standalone mixer, interface. I think that's what myself. Live recording with monitor mixing, studio input expander, output expander, optical converter, and of course you can create your own presets like I have there at the bottom. So and the presets are stored within the unit. It can store up to 100 presets, and those can be recalled from the front panel. So you know, stage use, live use, very easy to just dial up the different presets there. So let's have a look at the routing grid. So the routing grid controls all the routing between 4 different types of connections on the unit, inputs, and four families, I would say, of input outputs. There's the physical connections, you know, the physical jacks, XLRs, mic pre's, optical, SPDIF, physical ins and outs. That's easy to understand. There's also internal connections. They have a built-in mixer. The mixer has inputs and it has outputs. Now, in the previous generation of technology, those inputs to the mixer would be hardwired to the physical ins on the unit. So the only thing that could go into the internal mixer were physical ins on the unit. With the flexibility of these newer units, you can put in feeds from the computer can go direct into the mixer. Feeds from the network can go direct into the mixer. Basically, anything can go to anything else. It's incredibly powerful. So physical connections, internal connections, to and from the computer connections, and also network connections. So this is where you can select everything. It can look a bit fearsome, I'll admit, but you can. But essentially, once you've got to grips with it a bit, you'll see that generally you will be patching things on a kind of diagonal here. So,
Simon, we've
hello.
got a question on this.
Okay.
Where with this routing, is this only for the monitor mixer, or does this affect what actually goes into the input into the sequencer?
Yeah, very much it affects what can come in or go out of the sequencer. I mean, for example, we've been asked over the years, because a couple of the previous MOTU units have started to have the option to say decide, well, you have a headphone output on the front, and a sort of simple interface might just have that headphone output has exactly the same as what's coming out of your main output. Or you might want an independent monitor mix. But then people say, actually, I'd like to have what's coming out of the SPDIF. I want that on the headphones. Or people might say, actually, I want what's going out of the main outs to go out on these other 4 different pairs, because I want them going off to different units. And that hasn't been possible before. There's been a certain amount of deciding what goes out of the main outs. With this, if you wanted to have your sort of main 2 left and right mix feed from your DAW going out of every single stereo output pair, you could do that from this grid. You would just choose the main mix from computer 1, from computer 2, and just copy that all the way down the grid. You've got outputs on down the left hand side, inputs on the top row there. So yeah, very much it decouples the streams from the computer and the streams going into the computer, so that they can go anywhere you want. For example, one quite exciting thing I thought that you can do with it is just by calling up a different routing preset, rather than having outputs going out of a physical straight to the physical outputs of your interface, you could call up another routing preset and have them all go through into the internal mixer. The internal mixer can be controlled from an iPad over Wi-Fi, and there you're mixing the tracks from your DAW effectively on remotely. So some very exciting possibilities, I think. What can make this, what I found is to make things easy. All these things can collapse up, so you only need to look at the things that you need to see to make the routing somewhat simpler. Also, obviously these devices have got particularly like the 1248 66 channels inputs and outputs, you can turn on and off the ones that you need to make things simpler. So you're not sort of cluttering your routing grid with making it more complex than it needs to be. You can decide how many inputs you want in a mixer. You can decide the AVB streams that stream. We'll come to that later. Let's look at the mixer. So in the mixer, we can see there are filters, gates, EQs, different types of compressors. You can, as in with the routing, you can decide to hide and show different sections here if you're to make your screen more readable. You'll see these are grayed out as we enable. So they're grayed out as we enable sections of EQ. They become whatever the opposite to grayed out is, ungrayed out, and we can see the DSP usage creeping up as actually it's not budging at all, so I'd probably have to enable an awful lot to make it really creep up. So this is how you enable the different sections here. There's a reverb circuit available over here. Let's switch the reverb on. I see the DSP just nudged up when I did that. So just like a large format mixing console, you've got up to 48 channels of input. For inputs, you've got main outs, you've got monitor outs, you've got 14 channels of aux sends. We've got a special sort of aux mixing section here, so you can like home in on one particular send and focusing on how much gets sent for creating different monitor mixes is the sort of key reason for having that there. We've got high pass filters, we've got a noise gate. So plenty of audio toys to play with. For external control of the mixer, the OSC protocol is also supported and fully documented, so you can roll your own if you're into that and create your own control surfaces for controlling all of this. Okay, so let's get on to the nitty-gritty of the network port. This is where the magic comes in. Right. So first of all, the network port can be used simply for controlling the unit externally. You don't even need a computer to it controlled. You could have it connected up to a router or a wireless router, and then any device on the network that hosts a web browser can control it. As we talked, it could be an Android phone, could be an iPad. So decouples it from the computer. It's a great way to keep your interface up to date. As I said earlier, it will check when it's on the web. It will check if there is a firmware update available. Phones home, alerts you, and tells you. And it's very easy to update the firmware. And already there've been some great features added to that. One click to update. So the next thing we can do is to connect two AVB interfaces together. So all you need is a standard Ethernet Cat5 or Cat6 cable. Can be up to 100 meters in length. And hey presto, you've got two units talking to each other, streaming, uses an expander. Easy as that. No other equipment required. Just purely the inexpensive and standard cable. So you're combining the I/O of the units, you're combining the DSP of the units, so you're effectively doubling the DSP power. So the protocol that makes this work is called AVB Audio Networking. This is an industry standard protocol, stands for Audio Video Bridging. Think of it as high-performance, low-latency Ethernet for pro audio. It works just like Ethernet, uses standard cabling, you can use a standard AVB switch for expanding the network beyond the two units. It's reliable and it's simple to use. So we'll come on to this little box here, which is a MOTU AVB switch. I say you can use any standard AVB switch, but it so happens that I think this is one of the lowest cost ones on the market. It has 5 AVB ports. There's a 6th port for connecting into your network. 1 gigabit capability. So AVB is an open standard industry protocol. It's not a proprietary MOTU thing. It's developed by the IEEE, Institute of Electrical and Electronic Engineers. Lots of other manufacturers getting into it. We think it's the future of audio networking and transport. So here's the switch, 5 AVB ports, bridges to Ethernet. So here's what you can do with it. It opens up a whole load of possibilities for expanded systems, audio networking. With one switch, you could have up to 5 MOTU AVB interfaces connected in a network.
This nicely actually puts us on to one of the questions that's come in. Can multiple users on the same network have access to the same units?
Absolutely, yeah. So if I go on to the next slide, we see there's kind of a star arrangement there, and that kind of says it. So yes, every computer on there. So if we start adding this star arrangement, each switch then supports up to 4 connected interfaces. They also function as repeaters, so then we're beyond the 100-meter cable length there. Because you can go up to sort of 300 meters and beyond, and yes, so every host computer on imagine that diagram there can see every stream from every other place. So yeah, very powerful indeed. You can actually have hundreds of channels of audio in such a system. MOTU have tested up to 512 channels of audio running through a single AVB network. And it is simple to set up. You don't need to be particularly an IT geek to use it. You just plug them in, it recognizes them, a little bit of routing magic, and you're up and running. So what about latency on this kind of system? Well, AVB has been designed to have the specification of audio video bridging says there can be no more than 2 milliseconds of fixed latency delay throughout the system. That's a maximum figure. You'll never get more than 2 millimeter system with AVB. It's fixed. It's not variable like other networking protocols. It's fixed. But actually, MOTU's improved on that. They've really fine-tuned it so that every aspect of it gives the best possible performance. AVB has been designed to give what they call the guaranteed quality of service. That means there's a fixed bandwidth available for the audio signals. Once the network connection is established, nothing else is going to come in and interrupt it. It's dedicated to that. Hardwired system, backed up by the switches and the devices. That means it's completely reliable.
Is this what the difference is with an AVB switch to a normal switch, in that it prioritizes the audio in that way?
Yeah, I mean the audio. Well, I mean the V in AVB is video, so it's actually audio and video. So yeah, it's dedicated to this protocol, and optimized for that real time, low latency performance rather than just general network traffic.
Yeah.
Yeah. Clocking. Clocking is also part of the protocol. All the devices on the network follow a single grandmaster clock source. It can come from any interface on the network, whether it's their internal clock or an external clock plugged into the BNC for an external source. Really easy to set that up on the MOTU AVB app. I could probably show you that actually. Let's do that. If I go back here, so at the moment I've got my 1248 as the master. If I switch to my 24IO, go device, and here I just say become clock master. It tells me the following devices will be slaved, 1248, okay. Talk to each other established, and then that switches over. So I've got 2 devices here. I could have 20 devices, and it would be as easy, which is great. So other advantages of AVB, we just saw that window. So you can connect to a standard Ethernet network. You can have very long cable runs. It would work over an existing Ethernet installation. So if there's cabling already in the wall, then you're ready to have a full-blown AVB studio. So let's look at how MOTU have tweaked the AVB implementation to make it even better. So all the interfaces have got Thunderbolt and/or USB. So 1248, 16A, and 8M have got Thunderbolt, 24AO, AI, and Monitor 8 USB. So that means you can connect to a wide variety of computer. USB means you can connect to anything. Thunderbolt obviously is great for the latest generation Macintosh.
Are there any Windows Thunderbolt drivers?
They're in development. It's not released yet. Thunderbolt doesn't seem to have been adopted as widely as on Windows as it has been for Mac. So I think the priority was to get the USB support out for Windows, because that's going to work for everybody. But Thunderbolt Windows support is in the pipeline. Yeah,
we're just starting to really see it come through now.
Yeah,
across the board.
Right.
Certainly, we've now got a Thunderbolt audio laptop.
Cool.
So
wow.
Yeah. So it's very much the next thing to come through. I know there has been a delay from the Mac, but I think a lot of the Windows users will appreciate it. Though, to be fair, with the network capabilities of these, is the networking working on Windows?
Yeah.
Yes.
Yeah, because the networking's independent of once you've got one connection to the computer.
Yeah.
Then the networking is independent to that. So
with the extremely low latency.
But actually coming on to my next slide, actually, it's that the bandwidth available is, so it's like, yes, you can have it, but at the moment you'd be at 24 channels in, 24 channels out over USB, because USB 2, whereas Thunderbolt we can get 256 channels. Yeah. So in truth, when you're on a single interface, you don't need all that bandwidth of Thunderbolt is kind of going to waste. It's 10 gigabits, is it? So it's way in excess of what you need if you had 200 inputs and outputs on your audio interface. But when you start to add the units, all of a sudden, because it's the first one in line that's kind of taking that feed into the computer, the first one that's connected. After that, it's all on the network AVB connection.
Yeah.
So yes, for the real network possibilities. So technically it's there, but the USB would be the limiting factor at this moment on Windows.
Can you connect up solely on network on over Ethernet? So instead of connecting via USB or Thunderbolt?
Yes, you can on Mac on the latest Yosemite operating system with the latest AVB capable, the latest model Macs that have an AVB capable Ethernet port on them.
Right.
Yeah. So this literally just came in, I think, about 6 to 8 weeks ago. So AVB networking is part of what Apple are supporting directly.
Right.
So with Yosemite, so the very latest OS, very latest Mac, you can actually go Ethernet direct in.
But you have to have a AVB enabled Mac.
Yes. So I think it's kind of like the latest Mac Minis and the latest, the towers.
Yeah.
Yeah. So the very latest ones do support that directly.
But otherwise, you use one interface as basically a bridge between Thunderbolt and Ethernet.
And AVB, yes, exactly, yeah. That's right, yeah. So yes, with that you can pass at least 512 channels of audio through the network. So each MOTU device on the network can broadcast 128 channels out to the network and can receive up to 128 channels in. So when you start to build a network together, each one's got the 48 channel mixer with effects. So when they're connected to a network, they can pass the signals back and forth, as we saw on the routing grid, and it all just works as one single unified system. So inputs on one interface can benefit from the mixing and another DSP power in a different interface. It's mind-boggling stuff. So a standard AVB spec is that the latency can be no more than 2 milliseconds. MOTU have got that down to 0.625, which is pretty astonishing. So analog in to analog out at 48K over AVB, total 32 samples. That figure remains the same no matter how far the audio travels through the network. So even if it's going across multiple switches, all those hops across the network, it's the same. If you raise the sample rate, the converter latency is lowered, the number drops even further. So you get a delay of only 1 millisecond from one end of the network to the other. So fantastic performance.
Is the figure that you get there with the latency, is that in and out of the monitor mixer, or would that be what you actually see in your sequencer?
This is all to do with, this isn't a host latency.
Yes.
This is to do with latency within the system.
Yeah.
So you're passing, obviously once you're going in and out of a host DAW, that's, you're going through the driver and there's the computer becomes a factor.
Yeah.
So it's all a little bit how long is a piece of string. Obviously the drivers are optimized, but
yeah.
But with the network, it's a known quantity, so we can say that is the figure. Whereas I know what you're saying. DAW host latency is a different thing. But
yeah, if you were going to play through
the monitor through
interface.
So going back to this kind of diagram, that shows an expanded system, multiple AVB switches. You can have a different computer attached to its interface, and everything's talking to everything else. Very powerful system, and as easy to set up as just plugging in the cables. So all these products represent the future of connectivity, I/O, all complementary, stellar audio quality, effects processing, AVB networking, cool new web interface. Probably time for me to wrap up and take some questions, I think.
Cool. Well, I think we've about managed that as we've gone along. What we would like to say is remind people, fizzy balls.
Fizzy balls.
Fizzy balls.
Yeah.
If you were to perhaps email the word fizzy balls to webinar@scan.co.uk, we may well return your email with some very special offers on MOTU kit. Again, that's fizzy balls.
I should probably, I've brought on my next slide, of course. I haven't talked about the price of these units, so let's just get out there.
Well, let's finish it off.
So the first three units, the 1248, 8M, 16A, that came out last summer. Yes, it'll be shipping since last summer. All have a retail price, including VAT, of $11.99. The little AVB switch, £249. The 24 AI and AO, also in stock and shipping, £799 each, which is also the price for the Monitor 8, which I mentioned, which is the 6-channel headphone amplifier. So any other questions coming in from the interwebs?
No, I think we've about cleared everything today.
Okay.
Thank you very much for coming in. I can't tell you. In fact, I can say some of the stuff that Simon can't. In that, when they're comparing these interfaces, certainly if you read the on gear slots, it's going to be blatantly obvious. But the other interface of a similar stature, but without the networking capabilities, is of course the Apogee Ensemble, which has similar latency and it's also twice the price with the exact same converter in it. So very interesting to see what MOTU are providing. It's the same Sabre chip, and I'm a bit of a hi-fi buff, as everyone knows, with the Odyssey headphones connection. The Sabre chip is pretty much the pinnacle of conversion at the minute. It's implemented in almost every audiophile DAC on the market. So you really are getting something with this, which is access to that top level of conversion. And it's almost, I mean, it's almost like the networking stuff is free. You'd expect to pay that kind of money without the networking facilities. So thank you very much to Simon.
Yeah, you're welcome.
We don't quite know when our next broadcast is. At some point, I will be joining the lovely guys from Ulterior Motive down at their studio in Bournemouth for a producer masterclass. But in the meantime, we're moving into our new studio. So we will see you in a few weeks. Thanks a lot to Simon. Thanks a lot to Steve and Matt. We'll see you later.